Hey everyone, it's Mrs. Brimlow, and today we're going to start learning about our exponent rules with our first rule, the product rule. I've linked a copy of the notes in Canvas, or you can just follow along and get a copy when you return. Okay. So once again, we're discovering this rule, so I'm not telling you what it is. Math is all about finding patterns and then using them to make our lives easier and to help us solve more complex problems. So you're going to discover this on your own, but I'm going to get you started to hopefully help you see the pattern. So in the first column of this table, they give us some expressions. They want us to expand it out, figure out how many factors there are, and then rewrite the product as a power with your base and your exponent. And then I want you to think about this questions. How are the exponents in the first column and last column related? Okay. So just focusing on the first part of this problem, try to do it so you can see, we have 2 to the 4th. So I know an expanded form, that would be 2 times 2 times 2 times 2. Then we're multiplying that by the expression 2 to the 3rd, which is 2 times 2 times 2. Now, because they're all the same factors, I can count them up 1, 2, 3, 4, 5, 6, 7. And once again, because they're all the same number, I can rewrite this as 2 to the 7th power. Okay. So you're going to do that for the next two. And then once again, you're going to answer that first question. Look for a pattern between the exponents in the first column and the exponents in the last column. So I'd like you to pause the video, finish those last two rows, see if you can answer the question, then come back when you're finished. Okay. All right, so for the next expression, you should have had 3, because to the first, there's only one 3, times 3 to the 4th. So that would give us a total of 5 factors, which I can rewrite as 3 to the 5th. Okay. And then the last one is 5 squared, so 5 times 5 multiplied by 5 to the 4th. So in total, there were 6 factors, and that would be 5 to the 6th power. So once again, as I highlighted and as the question asks, what's the pattern between the exponents? Hopefully you were able to figure it out. If you weren't though, what you should notice is that when you're multiplying expressions with like bases, so they have the same number of variable base, you keep that base. So notice we had 2 for bases here in these expressions. We did in the end. So you keep the base and then you just add the exponents. 4 plus 3 is 7. And if you think about it, when expanded out, that's what we had to count to see in total. We added the total number of factors together to write that new power. Same thing here. 1, 3 plus 4 more 3s, total of 5 factors. 1 plus 4 is 5. 2 plus 4 is 6. And that's what we had in our final one. So how are the exponents in the first and last column related? The last column exponent is the sum of the exponents in the first column. So once again, sum is referring to addition. So that means the answer when adding the exponents in the first column gave you what you had in the last column. Okay. All right, so let's summarize this and write this a little more formally. So what is the rule that will always work? So the pattern we saw in each of those expressions and that we can apply to any problem that looks similar is that when multiplying exponential expressions, so just a little bit, with like bases, so meaning they have the same base, keep the base and add the exponents. If there are coefficients, I always have to sound this out, coefficients, multiply them. So I will pause for a second so you can pause the video, write this down. So once again, when multiplying exponential expressions with like bases, keep the base and add the exponents. If there are coefficients, so that means numbers in front of your bases, multiply them. That's the operation that's happening between the expressions. So that's what you apply to the coefficients. Exponents, though, you add them. Okay. All right, so write the rule. Basically, make a conjecture by representing the rule with variables. They're asking you to write it algebraically. Okay. So if I have x to the a power times x to the b power, I keep that base of x and I would add the exponents. Okay. So once again, we're in pre-algebra. You're all taking Algebra 1 next year. So we're really working on building our algebraic thinking and reasoning and being able to explain and justify our work using numbers, using explanations, and even using variables with rules like this. Okay. All right, can you use this rule we learned for this expression, 3 to the third times 7 to the third? Explain why or why not. I want you to pause the video, think about that, then come back and see how your answer compares to mine. Going back to the rule, it says when multiplying expressions with like bases. So that's the first thing I need to check. Do they have a like base? Otherwise, I can't use the rule. The base here is 3 and the base here is 7. Those are not like bases. Therefore, this rule doesn't apply. Even though they have the same exponent, that doesn't matter at all. You have to start with the bases. So can you use this rule? No, because the bases are different. Okay. So it would not work for a problem like this. All right, now let's do a couple of practice problems together, and then you can go ahead and work on what we have in Canvas or whatever you have in class. So this little think bubble over here, when in doubt, expand it out. So that's putting it in expanded form or repeated multiplication. I do encourage you to do that if you're still struggling and not seeing the rule yet. You will figure it out or catch on. But if you haven't figured it out yet, you can always go back to that. Okay. So our rule says like bases, you keep the base. So my base is 2, and then 3 plus 7 would be 10. Now on this next one, I have y as my base, and adding the exponents gives me 4. Next one, x is my base, 0 plus 7 is 7. I'm going to add 2 more examples. So I'm going to call this D. So I'm going to go ahead and pause the video to write this down. X to the fourth times x to the negative 2. So 7th grade, you spend a lot of time working on integers. So that is an expected skill in 8th grade. Rules still apply. Like base, you keep it, add the exponents. So that means I'm doing 4 plus negative 2. So since they're different signs, and I'm adding, I would actually end up subtracting, finding their difference. So that would end up being 2. Okay. So just, if you need a refresher on those integer rules, make sure you brush up on those. If you have questions, see me. Okay. The last one I want to do is, so in this example, you're going to notice that the base is x. How do I know that? I know that x is the base because that's what the exponents are attached to. That's what they're being raised from. So we learned in one of our previous lessons that when we have numbers in front of those bases or in front of those variables, those are coefficients. When you have coefficients, you apply whatever the operation is, okay? So that means I'm going to take 2 and multiply it by 3. That's how I'm going to start, which gives me 6, okay? And then now I'm going to use my product rule to figure out the exponent. So I have my base of x, and I keep my base, add my exponents. Okay. So when you have coefficients, once again, whatever operation you're working with, multiplication, division, whatever one you have, you're going to apply that to your coefficients. With your exponents, you're applying the rule. And if, once again, you need to expand it out, that will probably help you, especially with the coefficients. Okay. So once again, if you have questions, let me know. Make sure you get a copy of these notes if you're out. Check to see what your work is, and I will chat with you soon.